Hi, I'm Zor. Welcome to Unizor Education. We continue talking about ellipses, and today's topic is ellipse optics. Well, optics sounds like a topic from physics, well, and it is actually, but in this particular case we will concentrate on mathematical aspects of ellipse, which are, well, kind of, you can relate it to optics because it's about reflection. So what I actually mean is the following. Let's consider you have an ellipse and it has two foci, and let's assume that we are talking about two-dimensional case. Now, in theory, if we are talking about physics, it's supposed to be an ellipsoid if you will just rotate around the axis, around the main axis. But forget about the physics and forget about three-dimensional world. It's a two-dimensional world, and we have a contour of ellipse which we assume to be reflective, and I'll explain the details of this. So if it's like a mirror basically, okay, so what happens if you have a source of light here, and light goes to this point and reflects from the surface, and what's interesting is that the reflected ray will go exactly into the other focus of the ellipse. So that's the optics of ellipse. It takes any ray from one focus, this one or that one, anyway it's reflected, and the result will be in this particular other focus point of the ellipse. And well, what this lecture is about is to prove it. Okay, now first of all, let's concentrate on the process of reflection. Well, in case you have a straight line, and this is perpendicular normal to this straight line, if you have a ray of light at certain angle here, let's call it alpha, then it will reflect, and the law of reflection is that these two angles are the same. So this is incident ray, this is reflected ray. So correspondingly this is incidence angle and this is reflection angle. And this is how it is if there is a reflection against the straight line. Well, obviously these are equal, these two also are equal, because the sum of alpha plus this one is 90 degrees, and the sum of beta plus this one is 90 degrees. If alpha equals beta, then these two angles are also the same. But traditionally alpha and beta, which is angles with a normal, are called incidence and reflection angles. But if you would like to prove something, it doesn't really matter whether you prove alpha is equal to beta or this angle equals to this angle. Okay, that's fine, but we don't have the straight line here like this. We have a curve. So now we have to define what's the reflection of the curve. Well, and this is basically a very simple definition. We are talking about smooth curve, and in this particular case the curve has a tangential line. So let me just put tangential line here. This is tangential line, okay? So the law of reflection against a curve at particular point is exactly the same as the law of reflection against the tangential line to our curve at that particular point. So that's it. So instead of the curve, we change the curve to a tangential line, which is tangential in that particular point where the incident ray is directed. And then the law is, so if you have a perpendicular here, then these two angles are equal, perpendicular to tangential line, I mean. Or if you wish, these two angles. Just get this, because in our case I will use different angles. I will use these two angles. So I will prove that they are equal. So that's basically how we put the task in front of us. We have to prove that if this is an ellipse, this is any point on the ellipse tangential line, then if you will have a straight line from one focus into this and then another focus into the same line, then these two angles are the same. Okay? So that's what we have to do. All right. So what we will do is we will connect major with a major axis here, and we will have angles alpha, beta, phi, psi, and gamma. Now, every lecture which which you like, this one which you are watching, every lecture on Unizor.com has both video presentation linked to video and also a textual notes actually for the same lecture. Now the notes are in many cases quite detailed, like a textbook basically, and in this particular case I have a much better picture than I can draw. So I do recommend you, after you watch the lecture, read the notes. That would probably be very, very beneficial for you. Also, I will not present all the details of calculations here. I will just lead you to some formula which you just have to transform into something. In the notes, I actually put in writing all these transformations, so you can either do it yourself or read the notes. I suggest you to do it yourself, obviously. Alright, so let's talk about these angles. What do I know about the ellipse? Well, first of all, I know its Cartesian equation. X squared divided by a squared plus y squared divided by b squared is equal to 1, where if you remember, a squared is equal to c squared plus b squared. That was from the lecture which was preceding this one, where I basically explained what ellipse is, its main properties, and derived the equation, and this is one of the things. Now c is the difference between the length, 2c actually is the length between the foci. So this is f1, this is f2, this is point P, x, y, and our Cartesian system of coordinates has this is as x-axis and the y-axis is just in the middle perpendicular. Now a, by the way, is the coordinates, well, distance from the very end of the major axis to the center, or this one. So the whole thing between these two ends is 2a, and the vertical length is 2b, and c is length from 0 to any one of these foci. Okay, so again, that's all from the previous lecture. I just take it as given. Now, let's talk about angles. What can we say about angles? Look, angle phi I would like to express it in terms of alpha, beta, gamma, and angle psi I would like to present in the same way. And then, if I know alpha, beta, and gamma, I will be able to calculate phi and psi. So let's talk about phi. Now consider this triangle from this to this to this. Its angles are gamma plus phi plus this angle is pi minus alpha, right? Pi minus alpha. And sum of angles of any triangle is equal to pi, right? 180 degrees. From which follows that phi is equal to, so this goes out, alpha there with a plus, gamma with a minus, so that's what we have. Okay, let's put it here. Phi is equal to alpha minus gamma. Okay, now angle psi, if you will consider triangle from here to here to here, angle psi is external angle. It's supposed to be equal to sum of this and this. So psi is equal to gamma plus pi minus beta, from which psi is equal to gamma minus beta plus pi. Okay? So I have expressed angles phi and psi in terms of alpha, beta, and gamma. Now, if I know alpha, beta, and gamma, I will be able to calculate phi and psi, and I will be able to basically prove that they are equal. So that's my goal. Well, okay. Now, instead of proving that phi is equal to psi, I will prove that tangent phi is equal to tangent psi. Why? Because, well, look, tangent is a function with a period of pi. Now these angles are all below phi. If you remember, the graph of tangent is this. Oops, sorry. So this is 0, this is pi over 2, this is pi. So from 0 to pi, function is basically 1 to 1, well, except one particular point when the angle is equal to pi over 2, when tangent does not exist. In any other case, if you have a tangent, then you have an angle. And if you have negative, it will be here. So it's 1-to-1 correspondence within 0 to pi. And pi is a period, right? So within the period, tangent is function which gives you 1-to-1 correspondence between angles and the values of tangent. So I will just prove this one instead of proving that phi is equal to psi. Now, tangent of each one of them I can actually calculate, because tangent of phi is equal to tangent of alpha minus gamma, and tangent of psi is equal to, well, pi is a period of tangent, so it doesn't really matter whether I have pi or not. It's tangent of gamma minus beta. So if I will prove that these are equal to each other, that means that these will be equal to each other. Okay, now each one of them is tangent of difference between two angles, and we know the formula from trigonometry. So this one is equal to tangent alpha minus tangent gamma divided by 1 plus tangent alpha times tangent gamma, and this one is equal to tangent gamma minus tangent beta divided by 1 plus their product. Okay. So I will have to calculate these two and prove that they are equal to each other. Question mark. Whether they do or they don't. Okay, so that's my task. All I have to do is determine tangents alpha, gamma, and beta. Okay, so let's do it. So what my point right now is, I will show how to calculate all these tangents, and basically I will stop there, because I don't want to do all these algebraic manipulations and finally prove that they are equal. Again, that's something which you can do yourself, because it's just a straightforward algebraic manipulation. You just have to do it carefully, because they are kind of bulky, I would say. And in the notes for this lecture, which you can go to unizor.com, choose the course Math Plus for all, and choose geometry and Ellipse Optics topics. That's where you will find the lecture and other lectures, by the way, and the notes for this lecture. So all I'm concentrating right now is to calculate all these individual tangents, alpha, beta, and gamma. And that's it. After that, you're on your own. All right. If I have a line between 2 points in Cartesian system, let's say you have 2 points. This point is, let's say, P, x1, a1, and this is point Q, x2, y2. Now, you have this. Now, what is the angle which this particular line makes with the x-axis? Well, that's very easy. You do the parallel to x, parallel to y. So tangent of this angle and this angle are equal, because these are parallel lines. So it's this divided by this. That's the tangent there. So it's y1 minus y2 divided by x1 minus x2. This is the difference between ordinates. This is y1 and this is y2. So the difference is this. And this is the difference between abscissas. This is x1, this is x2, and the difference is this particular segment. So if you will divide one to another, you will have tangent. Simple, right? So that makes the calculation of tangents of alpha and beta very simple, because this has coordinates xy, this has coordinates, this is, the distance is c and c, right? So the coordinates of this point, so this is P, and my f1 has coordinates, abscissa is minus c, ordinate is 0, which makes angle tangents of angle alpha is equal to y minus 0 is y, x minus minus c is x plus c. That's it. Now, f2 has coordinates plus c and 0, which makes this angle, I'm talking about direction from the positive direction of x towards the this particular segment. So the tangent beta is equal to y, again, y is equal to 0, right? So y minus 0, so it's y divided by x minus c. Okay, done this. Next is tangent of gamma, and this is slightly more difficult because I don't know the coordinates of this point. I know this point, but I don't know this point, so I cannot use the same methodology. Have difference in y's divided by difference in x's. I do something else. Remember, and that's calculus, that the tangent of the angle, which, if you have a curve and at some point you have tangential line, then tangent of this is actually a derivative of this function. So if this is y is equal to f of x, then derivative at point x is tangent. This is the fact known from calculus, and I'm going to use it. So how can I do it? Well, very simply, I have an ellipse. Ellipse has this equation, right? Where y, if I assume that y is basically a function of x in this particular case, let's just differentiate by x the whole formula, left and right side. So this is the function of x and this is the function of x. Well, on the right side it happened to be constant. But I can make a, if functions are equal, then derivative is equal. So let's take derivative. Derivative of x squared is 2x divided by a squared plus derivative of y squared is 2y, but y is a function, which means there is a composition. Y is a function of x, so derivative by x is equal to derivative by y times derivative of y by x divided by b squared, and this is equal to 0, right? Because derivative of 1 is a constant. Okay, so what do? Obviously we cancel 2. We multiply by a squared b squared, so we will have x b squared plus y times y's derivative times a squared equals to 0, and y squared, I mean y derivative, this one, is equal to what? Minus x b squared divided by y a squared, right? So you put x b squared to the right with a minus sign, and then you just resolve it for I. So this is the formula for a derivative. And this is the same formula basically for tangent gamma, because derivative and tangents of tangential line are the same. That's the known fact. So tangent gamma is equal to minus x b squared divided by y a squared. So I have tangents of all my angles, and using the formula for tangent of difference between two angles, I can calculate tangent of phi using alpha and gamma, and tangent of psi using beta and gamma, and just compare these two formulas. And if you do it, you will see that these two formulas are exactly the same. Now, in this case, we are using C and A and B, but A and B and C are connected using this particular equality. That actually was again presented in the previous lecture, but basically it's related to a simple Pythagorean theorem. This is A, this is B, and this is C, and that's why you have this particular equation. This is the center, obviously. Okay, so this is all I wanted to say in this particular video presentation. As I was saying, the notes for this lecture contain complete calculations, which are, again, cumbersome, boring, whatever you want to say. But I've decided it's important to go through it, and I did it once. And yes, indeed, it proves that these two angles are equal, phi and psi. which proves basically the main optic quality of the ellipse. I do encourage you to try to do these calculations yourself, and then you can go and take a look at the notes for this lecture. And just as a side note, the website unizor.com contains not only this particular course called Math Plus for all, it also contains math for teens, it contains physics for teens, and some other courses. Okay, basically that's it for today. I again encourage you to do the calculations yourself, and good luck.